let's discuss the difference between linear functions and exponential functions. Here's an example of a typical linear function. If we take the Walmart sales for the years, say, 1996 to 2000, and here I'm not using the exact data. I've gone through and changed it just a bit, just to simplify it. What we're going to do is let x represent the years since 1996. So starting at 1996, x will be 0, and then x would be 1, 2, 3, and 4. For y, we're going to let that stand for the sales in billions of dollars. Okay, so in 1996, we're going to say that Walmart sold $105 billion in sales. Right? In 1997, 129 billion. In 1998, 153 billion. Then 177 billion, and then 201 billion. As I've said, this is slightly idealized. This is not the exact data. Notice that the difference here each year is that the sales increase by 24 billion. Right? 129 minus 105 leaves us with 24. 153 minus 129 leaves us with 24, and so on. Each one of these, there's a difference of 24. Okay? That tells us that this is a linear function. If we were going to plot this data on a graph, we'll have x and y. And then we'll let y go up here in increments, let's say, of 25. So I'm going to start it out at 100, and then go to 125, 150, 175, 200. Okay, if we plot the data points, when x is 0, we had y was 105 billion, so I'm going to plot that roughly about here. Okay, when x is 1, we had 129, so I'm going to plot that roughly here. When x is 2, 153. When x is 3, 177. And when x is 4, about 201. So what you'll notice is that these points fall in roughly a straight line. In fact, they fall exactly in a straight line, because I did tinker with the data so that it would happen that way, so that it would be a perfect line. But that would be our graph here for Walmart sales in billions of dollars. In the years here, marking from 1996. Okay, so that would be a linear function. I'll put that here. And you should be able to figure out what the equation is. The slope is 24, because we're increasing by 24 billion each time. And the y-intercept is 100, and so the equation of the line y equals mx plus b, y equals 24x plus 100. Alright, now that we've looked at that, we should also understand what the 24 represents. The slope tells us the rate of change. There's a constant rate of change in $24 billion in sales each year. And that's what characterizes a linear function. Okay, so now let's look at an example of a exponential function. For this one, we're going to take the example of investing money in an account. Okay, so we'll say beginning in 2000, we'll let that x be 0, and we'll say that we initially invested $1,000 into an account, and this account is going to give us 5% interest, and that's compounded annually. So with that 5% interest compounded annually, let's go ahead and look at how much money we would have in 10-year increments. So by the year 2010, we'll let x be 10. Our money will have grown to $1,628.89. By the year 2020, x would be 20. Our money will have grown to $2,653.30. By the year 2030, we will have $4,321.94, and then by the year 2040, x will be 40, y will be $7,039.99. Each year, we gain an additional 5% of the previous year's amount. Okay, now let's graph this data, plot a graph. With x here at 0, 10, 20, 30, and 40, representing the number of years since 2000. Okay, on the y-axis, we'll have the dollar amount, and we'll go up in increments of 1,000. So let's say it's 1,000, 2,000, 3, 4, 5, 6, 7. Move this out of the way. So now if we plot our data points in the year 2000, x is 0, y is 1,000, would be our first point. When x is 10, we had approximately 1,600. I'm going to estimate that to be here. The next point, 2653. The next, 4,321. And then finally in the year 2040 we had over 7,000. Put that about right here. What you'll notice here is that this is not a straight line increase, but that it curves upward. This is an example of exponential growth, not linear. The equation you should be able to guess, starting with an initial investment of $1,000. We have increased by 5%, so 1,000 times 1.05 raised to the x. Rather than have a constant growth, we don't have the same amount of money increase each year. The increase in money from year to year is actually getting larger. That's why we get this upward curve. And so what we actually do have, though, is a constant percentage increase. We have an increase of 5% each year. So with a linear function, we would say that there's a constant rate of change, a constant increase or decrease depending on the problem. But with an exponential function, we have a constant percentage rate of change. which gives us a curved graph.